basically what I'm going to do is if you go to View and then you go to Extensions in your Visual Studio Code and you type out Live Share, the first one that pops up is a real-time collaborative development from the comfort of your favorite tools. Right here where it says Reload Required, you would just click Install. It'll say Install right there. Click Install, get Live Share. You could see once you install Live Share, there'll be Start Collaboration Session down here. My buddy Brian recommended it to me, and I never looked back. This is the best tool. I try to use it for every single event. So you could see if I click Start Collaboration Session, Starting Collaboration Session, invitation link, copy the clipboard, send it to anyone you trust. So what I'm going to do is we're all in the lobby. If you're looking at my screen, I'm going to go right to resources and then right above that to chat. And I'm going to paste that right there. So now when you click this link, the first thing that's going to pop up is it's going to ask you if you want to open it in the browser or in Visual Studio Code. If you're given that option, open it up in Visual Studio Code because it's usually less buggy, but browser works as well. And then after you choose that option, it's going to say sign in as anonymous on the bottom right, or it's going to say sign in. If you sign in, you'll sign in with your GitHub, and that's usually less buggy as well, but I've seen anonymous work sometimes too. And if you don't want to use Live Share or you just can't use Live Share, sometimes people with Linux or other operating system or just like an older computer, they can't use it because it takes a certain amount of computational power. So if you don't want to or you can't, totally fine, just follow along on the screen. But for those who can, definitely I encourage you to do it because it's going to be more interactive and it's going to be a better learning experience for you. So you can see anonymous has come in. So when I go back to Explorer, okay, so we have Kevin and include. So we have 2 people in here so far. While everybody else comes in, I'm just going to open up the actual leak code problem so we could check out the problem together. Does anyone have any questions before we get started?
Can you also post the question in the chat as well?
Yeah, the link to the question?
Yes, please. Thank you.
Yeah, gotcha. This one was hard for me to articulate with Kevin the other day. We were like trying to make sense of it. All right, there we go. I just posted it. Okay. Cool. So we have Chris, Kevin, and whoever include is. And you can see when you're in here, this orange cursor is anonymous. This purple cursor is Kevin. Kevin, go ahead and highlight max increase keeping Skyline. You can see that when Kevin highlights it on his computer in his Visual Studio Code, I actually see what type something right in here, Kevin, in the function.
Over here.
Or over there, yeah. So when he makes edits, when he makes changes, I'm able to actually see the changes right there in Visual Studio Code. So that's why we use this right here. We actually use this for our team programming events as well, just because we could all work instead of like explaining Git and pull requests and version control and Node to all the newcomers. We all just make changes in one code editor together.
Better than sliced bread. This is awesome.
Oh, it's so good. I know. All right. So I'll give everybody just another minute to pop in, and then we will get started. And don't try to hide behind that mic because I'm going to be asking questions as well to people. Usually when I say that, you get like 1 or 2 people sign off like, screw this.
Right.
They're like, no. Cool. All right, so we have 3 people in here. All right, let's check out the problem. So let me just delete that. So there is a city composed of n by n blocks. That is a matrix. It's an array within an array, where each block contains a single building shaped like a vertical square prism. You are given a zero-indexed n by n integer matrix grid, where grid RC represents the height of the building located in the block at row R in column C. So let's just say you want to iterate through this entire matrix with a for loop and a for loop inside of that for loop. This would be the first target, this would be the second, this would be the third, this would be the fourth, this would be the fifth, this would be the sixth, and it slowly moves through it one by one. So we are allowed to increase the height of any number of buildings by any amount. The amount can be different per building. So let's just say 3, we're able to increase that to 5, or we're able to increase it to 10. But the height of a zero height building can also be increased. So if it's at 0, it can also be increased. However, increasing the height of a building should not affect the city's skyline from any cardinal direction. So that means, let's just say we're looking at the skyline from the west. There's someone standing over here and they're looking at the 3, the 2, the 9, and the 0. This is the skyline you're going to see. The red line is the skyline. You can see the purple is the 3 and the orange is the 8. So you would see that the 8 is higher than the 3, and that makes that part of the skyline. Then you can see the green is the 2, the orange is the 4, the yellow is the 5, the red is the 7. But since 7 is less than 8, the skyline drops down right there. Then you can see the 9, and the 9 is going to block the color from any of the other buildings. And then the last one, you could just see a 3, because obviously 0 is no height. You see the 3, you can't see the 1 or the 0 because they're behind that third building. And then if you look at it from the north, same thing from the north, same thing from the east. You're just looking at the buildings from a different direction, and same thing from the south. So basically what the goal of this problem is, you want to return the maximum total sum that the height of the buildings can be increased without changing the city skyline from any cardinal direction. So let's see, I'm going to pick on, let's see, include. Do you want to try to break down this, the problem? Do you want to try to explain it?
Sure. Yeah. I can try.
Cool.
Mm,
Let me know if you need me to scroll or anything. We do have you want me to, you want to use these examples or?
no, I understand what's going on in the problem.
Okay, cool.
Yeah. So it's 3, 8, 4. Oh, so do you want me to explain other than what you already said, or like?
Yeah. If you want to break down maybe like step by step what we're gonna be looking for the algorithm to do as we move through, or if you want to just use this input, the expected output, and then the explanation, just to break it down a little bit more.
Yeah, sure. So, well, I mean, as the problem states, we are not supposed to change the skyline or in any direction. So the only possible way we can do that is if we are trying to increase something, we need to make sure the ones on to the bottom of this one and the ones to the right of this one are exactly the same as it was. If not, we need to update the preceding values to the right or the ones in the bottom. So if you take any block in any direction, there is only 2 ways where we can mess up the skyline. That's horizontally or vertically. So whenever you're trying to add something to any block, you need to make sure the skyline is same. It doesn't have to be the exact values. Say, if you say 4, which is still the same height as this one.
This 4?
Yeah, let's say if you change this to 4. Oh, where did that go?
So what's the maximum we could increase this for and why?
Yeah. So if you go 4, it's still, well, from this direction, it shouldn't mess up. Let's say if you're viewing from this side, and if you say it 4,
From
it
north?
doesn't mess up anything. Yeah.
All right, so we're looking at the skyline from the north, and the algorithm is focused on this 4 value. What's the maximum we could increase this for without changing the skyline?
It's 4730, so we can do it 6.
6 would turn this 4 into 10, and then it would increase the skyline. So the skyline would end up being higher than 8.
We're not adding 6, we are adding 2.
To the 4?
Yeah, so it will be 6 overall. 4 plus 2, we can increase 2.
But then we want to increase it the maximum amount without changing the skyline. We could only increase it 2?
Well, wouldn't we say 3? So that way it can match us with 7?
Yeah, I guess.
Exactly, because we want to find the building that's the highest in any, like, say we're looking at this 4, we want to find the building that's the highest in the row, and we want to find the building that's the highest in the column, and then we have to compare the highest in the row with the highest in the column and increase our current building by whichever one is lower. Because if we increase this to 7, so we increase it by 3, then this skyline will not change. This 4 building will increase up to 7. It won't change the skyline. But if we increased it to 8, then it would increase the 4 past the 7 by 1. So that would change the skyline. So you have to take the highest in the row, the highest in the column, choose which one is the smaller one, and then basically subtract this value from whichever max is lower. Does that make sense?
Yeah, yep. Trying to figure out.
Okay, so I'm going to go over this example real quickly, and then I'm going to call on someone who said they're newer and in the boot camp and see what questions you guys have. So if we pass this matrix into our function, we want the expected output to be 35. So that means like this 3 is going to increase to 8, so it's going to increase by 5. This 0 is going to increase to 4, so that'll be 9 total so far. This 8 won't increase at all. This 4 will increase to 7, so that'll be 5 plus 4 is 9, plus 3 is 12, and it would slowly increase until it gets to 25. So the building heights are shown in the center of the above image right here. The skylines, when viewed from each cardinal direction, are drawn in red. So you can see those right there. You can't increase any higher than that. And the grid after increasing the height of buildings without affecting skylines looks like this. So you can see that that 3 becomes an 8, the 0 becomes a 4, 8 stays the same, 4 becomes a 7, the 2 becomes a 7. So we're basically moving through it one by one, finding the greatest in the row and the column, and then increasing the current building by whichever max is lower. Who has questions?
I have a quick question.
Yeah.
Yeah, so are you pretty much comparing like the value and the value into the grid?
Yeah, so you're comparing, let's just say our current value is 3. We want to compare this 3 to the maximum building in the row and the maximum building in the column.
Okay.
And then so the maximum in the row would be 8 and the maximum in the column would be 9. We want to increase this 3 from 3 to whatever one is lower. So the max is 8, the max in the column is 9, 8 is lower, So we'd only increase 3 to 8, because if we increase 3 to 9, this 3 building jumping from 3 to 9, from down here to 9 would actually increase the skyline. So we only want to increase it by 8. Does that make sense? I mean, by 5 to 8.
That helps a lot. Thank you.
All right, cool. So a couple more things that you want to think about, not just the problem, is the constraints. And I believe it was Include who mentioned you want to think about edge cases. Right? So the grid length is going to be, because you could see that the grid is actually an array with arrays inside of it, right? So n, or the grid length, in this example is 1, 2, 3, 4. So there's 4 blocks in this array. And then you can see that grid r dot length. So this is just saying grid r dot length is the number of columns. So you would see 3, 2.
That's a real mathematical way of saying you're always going to have a square.
You're always going to have a square. That's something I didn't realize when Kevin and I first solved the problem. So if the rows are 10, then the columns will also be 10. It's always going to be a perfect square, which kind of makes the problem a little easier. And then there will always be at least 2 blocks, and at most there will be 50. So at least there'll be 4 buildings, and at most we'll have 50 rows and 50 columns. And then the initial starting height of each one of the buildings, you can see grid RC is focusing on one particular building, and that's going to start anywhere from 0 to 100. So it might start at 0 like this, but it might start at 99, or it might start at 55. So those are the constraints of the problem. You know, it's always going to be within those bounds right there. So before we even get to, oh, someone else is trying to come in. So before we even get to the solution, I just want to show you, I want to go over like some quick ON stuff really quickly. So basically our solution looked like this. And this was totally brute force, not giving it too much thought. Actually, Kevin was giving it thought. I was just like, let's not think about it and let's just do it. So this was our initial structure. And then, so this is kind of giving a hint to the solution as well, but that's okay.
Would you say that brute force is just a way to kind of better understand the problem?
Yes.
Yeah,
Definitely.
I'd say so. Yeah, because we usually do brute force solutions first, and then we optimize if we can later.
Yeah, okay.
So this is what the solution looked like first. So this right here is an O of n cubed solution. And then this down here is an O of n squared plus n squared. So does anyone know why having this nested loop and this nested loop, so 2 nested loops, is better than having a loop inside of a loop inside of a loop? Do you know why it's better to just have 2 separate nested loops instead of 3 loops all inside each other? Just look at this and take a gander.
Well, I guess because the exponent where you have n is lower here than with this one right here.
Exactly. So it's the number of calculations being done. So let's assume that the length of grid is 100. All right. So n equals 100, right? Because if you look over here, you can see grid dot length equals n. So let's assume that there's 100 rows and 100 columns. So if we do it, if we solve it with this solution right here, it will be 100 times 100 times 100
Which is 1,000,000.
equals,
Just count
yeah,
to 0.
yeah,
Let me get my calculator.
I know, right? Which is a million calculations. So with this solution, if you have 100 rows and 100 columns, your algorithm is doing 1,000,000 calculations. But if you're doing O of n squared plus O of n squared, you know it's going to be 100 times 100, which is 10,000, plus 10,000 equals 20,000. So just think about how many less calculations you're doing with this style opposed to this style. You're literally
Yeah.
doing, what is it, 980,000 more calculations with this.
Yeah, like I think like no matter how big your input is, it's always better to have it in this runtime rather
Yes.
than
Yeah.
in that.
Always. Always.
Yeah.
Definitely. O of n cubed. I know, that was the first one we did. Okay.
Thank you.
That's awesome. Thank you.
Yeah, does anyone have any questions about that? All right, cool. We'll get to the solution then. Let me comment all this stuff out and just move it down so it's not distracting anybody.
One thing, what's stopping us from adding 100 like 100 more values for every block? The skyline will still be the same, right?
What do you mean?
Add 100 for everything, for
Like
every row.
like turning 3 into 100?
Yeah, 103, 100, 108, 104, 102. So
Because
just add 100 for every block.
you can't change the skyline from what it's starting as.
Is it?
But imagine adding 1 to every building and then just doing that over and over and over.
Yeah, I mean, the skyline will still be the same, right? It doesn't say anything about the max height of a building, or we are
Well,
not
True,
constrained.
true. That's a good point. Let me see. Return the maximum total sum that the height of the buildings can be increased without changing the city skyline. Okay, so without changing the city skyline. So if you push them up each 100, sure, it would still be the same shape, but it won't be like, it won't be 7 tall, 8 tall, 4 tall, 9 tall, you know?
well, wait, I don't think you can push it to 100 because in the constraints it has to the value of each grid has to be less than or equal to 100.
I
Right.
mean, that's the input constraint.
Yeah, but even hypothetically, it's saying, okay, it's saying that this skyline is starting at 7, 8, 4, 9, right? 7, 8, 4, 9. So if you added 50 to each one, it wouldn't be 7, 8, 4, 9 anymore. It'd be
Suppose it will not be
50.
7849, but the graph of the skyline will be the same.
The shape would be the same, but the value would be different.
True.
Yeah,
Right.
yeah,
The building facing them would be way taller.
yeah. Yeah, that's a good point, though. That's a really good question too. Because yeah, I mean, you could just add 50 to each one, and that's gonna be much higher than just turning 3 into an 8 and adding 5. But that would actually change the value of the skyline from 7, 8, 4, 9 to 57, 58, 54, 59. So I think that's what they're looking for, is they want the value of the skyline to stay the same. So, all right, so we can start building this solution now. What are we doing first? I put a little trick in here to see if this gets you guys too, so I want to see if anyone calls this out. What's the first thing you want to do? If you're new and you have a couple months in a boot camp too, don't don't hold back. You know, there's people we've had who are brand new, who've never typed a line of code in their life, and they gave their perspective. And we all have our unique way of solving problems. So definitely just shout it out. Feel free to yell. Making mistakes is actually the best part about this, because the more mistakes you make, the more you're gonna learn.
I guess. I would say it would be an integer number.
An integer number.
The result will declare what the result is first.
Always good to have a result variable.
Okay, so we will say result. So we will create the needed variables for the solution. All right, and the first one you're saying is going to be result, right? Do you want to initialize it to a value, or just leave it undefined for now?
We can initialize it to 0 for now.
Okay, cool.
Almost always better to initialize. Almost always.
Yeah, because if you go and try to add a number or a value to an undefined value later on, at least in JavaScript, it's going to give you not a number instead of an actual number. So definitely better to initialize it to 0 in this case. Are there any other variables that we should define? Think about this. Think about this. I showed you that the solution is going to have 2 nested loops. So is there something that we should define so we're not having to evaluate it on every new loop?
Rows and columns?
Yes. And that would be what?
I don't know. N and N?
N. So we're going to say N equals what?
Oh, that wouldn't be R and C. Sorry, I was trying to follow along there.
No, we don't have R and C yet. Not until we create the loops.
Oh, I see. I see.
With I and J, I think R and C is much more illustrative and.
Oh, it's way more clear. I mean, I know everybody teaches I and J, but
call myself.
Yeah, that's so much easier. It's so much more clear, and that's how you want to write your code, to not need as many comments, to just be as clear as possible. So we're going to define the number of rows and the number of columns, and how would we do that? We'll call it the number of rows and the number of columns. How would we do that? Well, we could look at the constraints and figure that out.
Don't we need to pass the building array into the function?
That's what I didn't know if someone was gonna catch that. All right, there you go. Nice. I was hoping that we were gonna make it till the end, and then we're gonna encounter an error, and it's like grid is undefined. Okay. All right. So how do we set the length? Well, we do know that the columns is going to be the same as the rows, right? So this is how you get the column right here. Grid brackets r dot length. And this is how you get the rows right here. So I'll go ahead and type that out. It's just grid dot length. So we're taking 1, 2, 3, 4 elements in the grid that we pass in. And so this n will be set to 4. At least with this problem right here. All right. Anything else?
Somehow there has to be an array in this, but maybe you did that above.
I'm going to go ahead and just do let result equal 0, because this 0 is going to change. This length is never going to change. So I'm just going to initialize that as a constant.
And
I have a
is our array.
Oh.
We do need 2 arrays.
I have a suggestion. Well, it's mainly like doing these problems in general.
Yeah.
Would it be okay if we have, you know, like a separate comment section where, you know, when we're, you know, testing the algorithm or running it, we create like the variable names just to keep track of them. Like,
I don't
you
know
know,
what
like
you
for
mean.
example, oh, let me try to show it. Like, let's say I have this comment. So if you say, you know, let result equal 0, so far we know that the result is 0. And then we have n. We know that the grid length is going to be 4, so we'll keep track of that as 4. And
Okay.
so while we continue writing the algorithm, we'll keep track of these variables.
Okay, cool. Yeah.
Would that be helpful?
Yeah, that's cool.
Okay.
Yeah, I remember when I first started doing these things, I would just put them in I would put them in the browser and I would do them like I'd do them down here and I would just it was in sources, I believe. Yeah, I would do a new snippet. I'd paste my solution and then I'd pause it and then I'd go to the next step. So I'd literally walk through solutions like step by step. So definitely I used to do that. It was really people like made fun of me. They're like, "You're a robot, bro." But yeah, if they help you learn, I don't see why not. All right, so what's next?
If we have like the dimensions of the grid, right? Maybe we can spend some time iterating through and figuring out like the maximum height in each row and each column, so that way we don't have to like do that extra work again.
Correctamundo.
Perfect. So we'll create like a row maxes array and a column maxes array, and we'll store the maxes from the columns and the rows in those arrays.
I can't help myself because we know n. Declaring those as size n will be a little bit more efficient.
As size n, that's a really, really good point, Kev. So let's do
Arrays aren't going to change size.
let row maxes equals, so we're doing array n, right?
Mm-hmm.
Then let col maxes equals array n. So I'm going to leave it like that right now. If we come across an error, then we come across an error.
It'll be fine.
All right, so I believe these are the variables that we need for the solution. Let me know if there's anything else anyone wants to add before we move on to the actual algorithm. Nobody? All right. So, I mean, I kind of already said what we're doing. You know, we did this one on the first time, but the double nested loop ended up being the more efficient solution. So, does someone want to type these out? Chris or Kev, since you guys are the ones in the code editor right now?
Oh, I'm sorry. What was the question again?
Oh, I was just going to say, one of you guys can type out the for loops if you want.
I mean, I can try. I mean,
Yeah, give it a
I'm
shot. Why
mostly
not?
used, I'm mostly used to Python, so I'm not sure about writing raw JavaScript, but I'll give it a shot.
Yeah.
I guess. something like that.
Yeah, that's actually great. I'm just
Oh,
going
okay.
to change
How about we
these
make
to R,
array in the column? Yeah, at least
Oh,
R and
okay.
C.
and then we'll come back to that. All right, go ahead.
And I guess the next one is for column. C would be for column, and then C. Yeah.
Perfect. These are just little things we'll come back to later. No sweat.
Yeah. I guess as far as we know so far, it looks like the runtime is going to be big O of n squared so far.
Yes. Big O of n squared with just these two for loops right here. So
Yeah.
what do we have to do right here? Because basically, let me add a comment real quickly. So this double for loop is going to be used to find the maximum value in each row and column. So that's what this one's doing. And then we'll create another one down here, just for like to find out how much each building can be increased, I guess. And then
Not just find out, add up how much.
yeah, and then add the possible increases in the results variable. So this one is just to find and store the maxes in each row and column, and this one is to actually do the math on how much each specific target can be increased compared to the max row or column, and then increase it. So how are we actually going to write this one right here? Find the max. How are we going to find the maximum value in each row and column? And if someone who's not doing any typing wants to chime in, just shoot it out there. Just take a guess if you want. So we're iterating through these two. We're iterating through the rows and we're iterating through the columns. So on the first iteration, R is set to 0. So we're going to be focused on this right here, right? So we know that on the first loop through this loop right here, we're going to be focused on this 3. We could, if we type, let me just type this out, grid R C, that's going to give us this 3 on the first iteration. Then it would give us this, then it would give us this, then it would give us this. But we're also going to use these.
Max function, can you hand it a comma separated list?
An array?
Well, no, a list.
A list of numbers? Yes.
Yeah.
Yes.
Because to find the max in a column, say the column is 2, you'd hand it 8, 5, 6, and 1, and maybe we could drop one loop out of there.
Type it out, Kev.
It's not fully formed in my head yet. let me think a little more. But I think
Type it out down here if you want, and then we'll try to unplug this and plug in yours if you want.
Let me play around here.
So basically, with this array and this array right here, you know that you're going to get an array with 4 elements. So row maxes is going to be, you got this. It's going to be, it's actually going to look like this. So before we even do anything to this algorithm, what I'm going to do is I'm just going to fill each one of these arrays with zeros. You do that just like this. We would have gotten an error if we didn't do this. So now these arrays actually look like this. So to give you guys a hint, what we want to do is we want to compare this value and this value. With each iteration of this loop, we want to compare this value and this value with the current greatest. So on the first iteration, it's going to be targeted on 0 and 0. On the next iteration, it's going to still targeted 0 and this one. And the next one is going to be this one and this one. And then this next one is going to be this one and this one. And then we're going to move through the loop. So here, this is what I'll do. I'm going to type out what I think it is for the row, and then I'm going to let someone else type it out for the column, which is pretty similar. Actually, there's just a couple modifications. So I believe it's, so row maxes are, so we want to overwrite row maxes 0 with whatever the greatest in that row is going to be. So we'll use math.max, and we'll do we'll compare row maxes R and grid RC. So let's just say we enter this for loop, R is 0, we enter this for loop, C is 0. You know that this is row max is 0, so we're actually focused on this element right here, and we're going to compare the current row max is 0, row max is R, which is 0, with grid RC, which is 3, right? Because 0, 0. We know that 3 is greater than the current value of 0, so we store 3 in here, and now row maxes equals this. Then I'm not even counting column maxes right now. We are going to have to add a line for column maxes, but let's just focus on row maxes right now. So on the next iteration, this is still gonna equal 1. This is gonna equal 0. This is gonna equal 1 right here. So it's gonna be grid 0, 1. So we're actually gonna be focused on this one, this 0 right here. So now row max is 0 is equal to 3 because we just overwrote this 0 on the last one. We're comparing row maxes R, which equals 3, to grid RC, which equals 0. Since 3 is larger than 0, same thing. We're just storing that 3, and this doesn't change at all. All right. Then we're going to go through this loop again. C is now equal to 2. R is still equal to 0. So we're going to be focused on this 8 right now. So what we're going to do is we're going to take the current value, row max is 0, because this R still equals 0. So we're still comparing, this is 3, to grid RC, which is 8, because grid 0, 2. This is the 0 element, and this is the 2 within that. This equals 8. Since 8 is the max in this method right here, it's greater than the 3, we're actually going to take this 8 and we're going to store it in there. So we're changing that to 8. And then we have one more with this loop right here, right? So this C is going to equal 3. Row maxes is still, row max is 0. That's going to equal 8. We're still focused on row max is 0, which is 8. We're comparing that to grid RC, which is grid 0, 3, so 4. And since 8 is larger than 4, row maxes R, or row max is 0, is equal to 8. Then, that's the last one for this one. Then we change R to 1. So we basically do the same thing we just did there, but instead of, we have the max now, right? We have the max in the row is 3. I mean, is 8. But when we compare the 3 to it, we know that the most we could increase the 3 to is 8. But we're actually going to use this 8, and we need to find a way to turn this column axis into a 9. So does anyone want to give it a shot? We're basically writing a line of code right here. We want to do column axis C equals what? Go ahead, someone give it a shot.
Math.random. I'm math.max.
Math.max. Then what?
We'll compare the column max again. So we're comparing the column max of the column, right?
Of the column? With what?
Then it'll be the grid of the column and the row.
Column and row, or row and column?
Column and row, yeah.
All right, so let's go through this and try this out. So basically, it's going to be 0 and 0 on the first iteration, right? So it'll be column max is 0. So we're focused on this right here, the 0 index. This is starting off as 0, and grid CR is also 0, 0, right? So we're focused on this 3 right here. So we would take that 3, we'd store it in here. Now this value would be 3. So on the next iteration, C is going to equal 1. So we're going to take column max is C, which evaluates down to 3, and grid CR, which is grid 1, 0, right?
The second time through, when C is 1, column max 1 is going to come back to 0.
Column max, we're actually moving from the first index to the second index with the next iteration.
Yes.
Yeah, because C equals 1. So we're not focused on this 3 anymore. We're actually moving to the next column. So column max is C would equal 1, which equals 0. And then grid CR would be, in this example right here, it's 1, 0. Right? So we're looking at this second index right here. So we change that to 2, right? And then we'd be looking at column maxes C or 2 and grid 2, 0. So we'd be focusing on this right here, and we'd be comparing it to this 9. 9 is obviously greater than 0. So we'd have that there. And then we would change this to 3. Column max is 3. Compare column max is 3, which is 0. And grid CR, which is 0, would leave us with 0 right there. So the thing is, we're going to need this 9 to be in the first spot for comparing in this algorithm. So how can we move this 9 to the first spot? How can we change this right here so that it builds this array differently and it puts the 9 here? It's a really, really simple change.
Could you swap around the C and the R in the grid?
Exactly. Yep. So now you could see if we did it differently now. Obviously this is starting at 0, RC 3. C is going to change, so we're going to still move to this one right here. But now we're going to be looking at this 0, so that's going to stay 0. Go through the loop again. This is going to be 2, so it'll be 0, 2. So we're comparing this 0 to this 8. And then we'll change this to 3. So column max is C equals 0, and grid 0, 3 is 4. So after R,
It was always the same.
yeah, so columns, the entire array is being updated every single iteration through this for loop, this nested for loop. But with the rows, we're just doing one index at a time. So eventually, this rows would end up being 8, 7, 9, 3, I believe, and this would end up being 9, 4, 8, 7 eventually.
Why don't we run it and spit out row maxes, column maxes, have a looky look.
Yep. So let's check what each one looks like afterwards. Make sure this is good so far.
Yeah, the thing I was thinking wouldn't work because it'd be based on a fixed number.
Okay, I gotcha. Okay, so let's run node problem.js. Yes, so 87939487. So these are the maxes. These are the maxes in the rows. These are the maxes in the columns. So on the first iteration through these nested loops, we're going to be trying to take this 8, this 9, figuring out which one is smaller, and then subtracting the current building that we're on from that to see how much we can add. So this looks good. The console.log came out with an array that looks accurate as far as the maxes go. So the next step would be
The rest
build
is gravy.
the what?
The rest of this is gravy.
Easy, smooth sailing from this point on. Who hasn't participated yet? Let's see. We got JB. Are you in here? No, we only have Tenchi. You're in here. You want to write out these for loops?
Yeah, I can give it a try. So,
Did you just type out the last ones?
no.
Oh, okay. Does anyone have any questions about this nested for loop right here?
It seems like it's a pretty straightforward solution, but kind of breaking it down to get to the solution's the tricky part.
Yeah.
Yes.
I always get a little tripped up by matrices still.
Yeah, I think that should work. And then yeah, so something like this. And I don't think you have to actually modify the original grid, just because the constraints of the problem, right? Like the skyline theoretically shouldn't change, right? So this should be okay.
Yeah. Yeah, that looks
Why do you
good.
use the minimal method?
Good question. Do you want to answer that? Tenchi,
What
since
was
you...
asked?
So why'd you use the minimal method? What does that find?
I won't. Yeah, so like mathmin, mathmax just finds like, so if you give it like a couple inputs or something like that, right? Then it spends like on time like figuring out like, okay, well this is going to be the maximum or the minimum number. Since it's like two numbers here, this is like essentially like an O1 operation, right? So it just gets the minimum between like this input and this input. I don't know if JavaScript mathmin can handle more like 3 or 4 inputs, but I'm sure it could also find the minimum for like a given array or something like that.
So it finds the minimum value between those two values, then it subtracts it from the grid.
Yeah, so that's kind of the idea. So I think like the problem, the skylines, like the idea is like you're on a specific position inside of like a grid of buildings, right? When you're in that specific position, you want to figure out like how much can you increase the building height in order for it to like not change the skyline, right? And for that to be the case, it's like imperative that you don't change. Like you have to look in both the row and the column because if you just do one, you might eliminate the view of the skyline in the other, if that makes any sense.
Okay, so you have to search the row and the column.
Yeah.
Right? And that's really key to the whole solution.
Yeah, exactly. So basically what we saw, these are the two arrays that we have after we build the column maxes and the row maxes. So let's just put those right here really quickly to make this easier for everybody else. So basically when we're looping through this, what we're doing is we just want to find out how much can be increased. We know by the picture that when we're targeted this 3 right here, we want to increase this 3 without increasing the skyline. So if we increase this 3 to 8, we're increasing this 3 by 5 up to 8. And still, if you look at it from the north, you could see the 3 right here. If you increase it to 8, then the 9 is still a little bit taller than 8, and you never change the skyline. But if you change this 3 to a 9 instead of an 8, so the max on the column side, then this 3 would be a 9. It would increase and it wouldn't change the skyline on the north. But if you look at the skyline from the west, this 3 would become a 9. And it would actually push this skyline up by 1 from the west. So the reason why he has this min right here is he doesn't want to find the maximum. He wants to take the two maximums, so the 8 and the 9, and you can see in the arrays that we made, the 8 and the 9, and he wants to find the smaller one because you want to increase this grid RC, or the first one's going to be 3, up to 8. You only want to increase it up to 8, not up to 9. That way it doesn't modify the value of the skyline.
And then what gets added to result is 5.
Yes. So so this math min on the first iteration, we have 8 row maxes R, because R equals 0 is going to be 8. Column max is C, so column max is 0 is going to be 9. Since 8 is lower than 9, math.min evaluates down to 8, and then we subtract 3 from 8, which evaluates down to 5, and we take the result, which is 0, plus the 5 that's returned from this whole evaluation, and the new result equals 5. So just to go to the next example, you can see that then C will change into 1. So row maxes R will still be 8. Column maxes C will be 1. So that's here. That's 4 right here. So you can see that 4 compared to 8, 4 is less than 8. So this math.min would evaluate down to 4. We take this grid 0, 1. So this 0 right here. And we do 4 minus 0. So this whole thing would evaluate down to 4. You take the result that was 5 before, and you'd add 5 to 4, and now you'd have 9. So this 0 right here. So this 3 would equal 8, and this 0 will now equal 4. Does that make sense? And then you're literally just going through the grid RC one by one. So it's going to be grid 0, 0, grid 0, 1, grid 0, 2, grid 0, 3. Then it's going to go to grid 1, 0, grid 1, 1, grid 1, 2, grid 1, 3. Then it's going to go to grid 2, 0, 2, 1, 2, 2, 2, 3. So you're literally just going 1, 2, 3, 4. You're going through the matrix one by one from beginning to end. And with each building, because each one of these numbers or each one of these values is abstractly, metaphorically, a building of its own. So we're taking the building on each iteration. We're using the max in each row and column to figure out how many we can add to each one of these buildings without pushing past the skyline from the row or the column. Does that make sense? Let's test it out. Who has questions? Because nobody said, yeah, that makes sense when I said, did that make sense? No questions.
Yeah,
Go
it
ahead.
makes sense to me. My question would just be refactoring it, seeing it a different way afterwards.
Definitely. Okay, cool. And then
It is refactored.
old text, what are you thinking? Everything makes sense?
Yeah, it makes sense. I think I spent too much time getting
It
tripped
makes
up on
sense.
the different directions in the beginning. That would have killed me on time.
Definitely. Who else we got here? Mandy Mason?
Yeah. I'm also in the coding boot camp, and all this is all really new. It's really cool to see how everything works. I'm probably a little lost at actually helping figure anything out, but really cool, really interesting.
Totally fine. That's awesome. On the Saturday nights when we do the coding competitions, I still get tripped up too. Like, I usually solve the first and the second one easy peasy, but then the third one I get a little stuck on sometimes. And then there's always someone sharing the third and the fourth solution. And that's probably how you're feeling right now, where it's like, it's exposure, which is great. So you're seeing it. But there's so many times where I'm like, it's late and I'm like, just focus, listen to every word, try to understand this. And I'm listening. I'm so focused. I'm hearing every word they're saying and they're explaining everything so clear, but I just can't wrap my head around it. I'm like, I just don't get it.
Yeah, like understanding the problem and like where we're going with that is, I get all that, it's fine, but just seeing, the way you write it out in the code, because I've, only been doing it for, I don't know, less than 8 weeks.
Yeah.
And a lot of that was just very, very beginner stuff. So a lot of this is the kind of stuff we're working with right now in our
Awesome.
classes and everything. So,
This is not
seeing your
this is
solution,
not a
everything's
beginner level
really cool,
problem.
really helpful.
Awesome. So you probably know, like, you've seen arrays, you know what variables are, you know what this n means. It's
Oh,
just as far as like
yeah.
grid
Yeah, definitely.
RC and column this stuff could get a little
We
confusing.
haven't worked with matrices or anything yet, but the arrays and variables and all of that definitely.
Cool. Cool. And then who else we got here? Dave, what's up? Welcome back.
Oh, can you hear me?
Yeah.
Hey, Jimmy, how you doing?
Pretty good.
I'm sorry I joined a little bit late, but yeah, towards the end it was making sense, which is good. But yeah, it was kind of nice to see that you're talking the big O notation at the beginning, because that's something like for me that's like a major review, and sometimes certain employers don't really talk about it, but lately it's been a big deal. So it's nice seeing that in the beginning in terms of efficiency, coming up with the right solution. That was kind of nice to see. So
Awesome.
Yep.
Cool, cool. Lauren, you're newer, right? How was this for you?
Good. Yep. If they hadn't had that picture on the problem, I probably would still be wondering what's going on. But once I was like, oh, it's a box. Yep.
Okay, cool. Awesome.
Yeah. Yeah, I kind of felt the same way. Like, I think if the diagram wasn't there, I probably wouldn't be able to understand it.
Yeah,
So, yeah.
yeah. That definitely makes it easier to wrap your head around for sure. Let's see. Anyone else? Breading 234. You're newer to the server. How was it for you?
Yeah, today was a little bit different. Yeah, today's my first day here in the program.
Awesome.
I'm kind of familiar with a lot of arrays and matrices and vectors. So like, working with numbers is kind of one of my niches.
Awesome. Awesome. Well, thanks for joining. Let's test this bad boy out. Let's see what we got here. So we are running a max increase keeping skyline. We're passing the matrix in here. So what are we expecting here? So this is the one we passed in right here. We're expecting 35. Let's see what we get.
To rim out some stuff.
Huh?
You need to rim out some stuff or you throw an error.
Rem out?
Yeah, like the two where you showed the actual arrays and then the two console logs. Console logs on error, but the array.
Yeah. True. All right. Let's see what we got. Node problem.js 35. Perfect. So we're getting what we expected.
All that for one lousy number.
I know, right?
I think we should take the code and paste it onto lead code, and then we can probably do more tests because I think it has a built-in.
It does, yeah.
Yeah, like I think you can do tests on there. So.
If we run code.
Well, then again, you guys probably use a lot of lead code, so.
Oh wait.
I think you got rid of the method signature.
Yeah, I didn't get the I didn't get the bottom or the top. Oops. Let's try this again. I wonder what the efficiency is as well. Yeah. So if we submit it. Oh yeah.
Oh, that's so much better than our first one.
Yeah, the first one it came out as like 5 or 6% on each one. It was really horrible. So the O n cubed was just bad. Then we ran a solution similar to this, but it was still kind of low, under 10% on each side for some reason. So this is beautiful. This is exactly what you want. And you can see, look at the milliseconds compared to.
Couldn't we still tweak the first for loops, the first two for loops?
Oh yeah, we could actually. If we put these pluses before, it's gonna save